power rule worksheet, so let's go through this. Assume f prime of 1 equals 3 and g prime of 1 equals 5. Find each using the methods currently covered. So using the methods we currently know, we're going to find each of these. So f minus g prime. So we can separate this and get it f prime of 1 minus g prime of 1. And now we know f prime of 1 equals 3 and g prime of 1 equals 5. So you get negative 2. Over here, similar idea, we can split it up. G f prime of 1 plus 2 times g prime of 1. I meant f of 1 earlier. So we have that. F of 1 is 3 and g of 1 is 5. So you get 9 plus 10, or 19. F times g prime. Now we actually don't know yet how to, we're not supposed to know yet how to do this. So not possible. We can't just you can't just separate it. It doesn't work that when you multiply. Multiply is a more complicated thing. It works like that for adding, subtracting, just split them up, but not for multiplication. So not possible yet. I should say not yet covered, probably more accurate. Not yet covered. Okay, to which of these does the power rule apply? So now remember the power rule works with the power function. The power function is a variable to a number power, to a constant. So that's what we're looking for. We're looking for a variable to a constant. Well, the first one, the perfect example. B, same idea. E looks scary, but it's just a number. It's 2.71 blah, blah, blah. So that's also power rule. X dx, not good. Those are two variables. 2 to the e, that's just a number. Like that's all that is. It's like 2 cubed, but instead of 2 cubed, it's 2.2 to the 2 point blah, blah, blah. XD, that's an exponential. When the variable's on top, we call that an exponential, so not that one. And then here, x to the negative 4/5. That fits our criteria. It's a variable to a power. So we could do the power rule there also. So there we go with that. P5, does the power rule apply to f of x equals the fifth root of x? Explain. Well, if we rewrite this, we get x to the 1/5. So yes, it does apply. Because it's a power function, square root function. What is the slope of the tangent line to y equals ex at x equals 0? What about the y equals 7ex? So key thing here is slope of a tangent line is just code for the derivative. So we just want to know what's the derivative at y equals ex. So y equals ex, take a derivative. Derivative ex is just ex, so we just get ex. Now they want us to substitute 0, so let's do that. E to the 0, that is just 1. Y equals 7ex, so the derivative of that, well, the 7 stays as a constant, so we just get ex, 7ex. And then y prime of 0, we're going to sub it in. 7 times e to the 0, which will just be 7 times 1, which would equal 7. Aren't e's great? Okay, let's move on. So we want to take a derivative of x to the 4th at x equals negative 2. So derivative of x to the 4th, just bring it down, subtract 1 off. I get 4x cubed, and now we want to sub in negative 2. So 4 times negative 2 cubed, 4 times negative 8, which equals negative 32. Next one, 4x to the negative 4. So bring it down, subtract 1 off. Negative 4x to the negative 5. Plug in 3. So negative 4, 3 to negative 5. Now we're going to simplify that, so let's move this down. So negative 4 over 3 to the 5th. So remember the negative power, you just flip it, nothing else changes. 3 to the 5th is 243. So I get negative 4 over 243. Next one. Take derivative t to 2/3. So we're bringing down the 2/3, subtract 1 off. 3 over 3. So I get 2/3 t to the negative 1/3. And now we're going to sub in 8. So there's another one where I'm going to flip this. Let's flip the power down first. So I'm going to get 2/3 times 1 over 8 to the 1/3. Like that. Right? Flip it down. There's a 1 on top. So I get this. 1/3 is the same thing as cube root of 8. So that's just going to get us 2/3 times cube root of 8, which is just 2. And then these cancel, so I just get 1/3. Next one, t to the negative 2/3. So bring it down, subtract 1 off. Common denominator. So I get negative 2/3 t to the negative 5/3. And now we're going to sub in that t equals 1. So negative 2/3 times 1 to the negative 5/3. Well, that part's easy, just 1. So negative 2/3. Okay, let's move down to the next step. So for all these, we want to find the derivative of each. So the first one, now it's t to the radical 17. It looks scary, but radical 17 is just a number, so we're going to treat it the exact same way. Bring it down, subtract 1 off. So rad 17, t to the rad 17 minus 1. That's all I could do. I mean, that's it. Next one, kind of the same idea. I know it looks scary, it's just a number. So do the same thing. Bring it down, subtract 1 off. Negative pi squared, t to the negative pi squared minus 1. Done. Now we get some more basic ones, right? So just power roll all this stuff. Bring it down, subtract 1 off. So 6x squared. Bring it down, subtract 1 off. Minus 6x. Right here, plus 2. Remember, anytime it's a linear term, just an x there, just get rid of the x. It's all the coefficient. So anytime it's linear, just the number in front. And that's the derivative. Next one, more of the same. Bring it down, subtract 1 off. 6x squared. Bring it down, subtract 1 off. Plus 10 x to the negative 2. Right? Negative 1 times negative 10 is positive 10. Negative 1 minus 1, negative 2. That's good. If I make it pretty, I'd make that. That's fine. Whatever. I restarted it. 6x squared plus 10 over x squared. If you want to go the extra mile. Next one, same idea. Just take a derivative, bring it down, subtract 1 off. Negative 21z to the negative 4. Bring it down, subtract 1 off. 2z to the first. Now plus 5. 5 is a constant. The derivative constant is automatically 0, so it just goes to 0, goes away. So that's our answer. Next one, I gotta do a little work first. And this is always gets people mixed up. So before you take any derivatives, just rewrite it. So this is the same thing as saying 6t to the 1/2 plus 1 over t to the 1/2. Or if you're pro, well, we gotta do it anyway. We can't have a variable on the bottom, we gotta move it up. 6t to the 1/2 plus t to the negative 1/2. Okay, so now keep in mind, we haven't done any calculus. All we did was algebra. So what we're going to do now is take a derivative. So this is still h of t. I want h prime of t. So we're going to bring the 1/2 down, subtract 1 off. So I get 1/2 times 6 is 3. Common denominator, I get t to the negative 1/2 plus, bring it down, subtract 1 off. I guess that makes it a minus 1/2 t to the common denominator, 2 over 2, negative 3/2. There we go. More on this side. Okay, just like before. Before you start taking derivatives, rewrite it all. So this is the same thing as s to the 1/4 plus s to the 1/3. Now we can just take a derivative. I use that number. So now the derivative at s would be, bring it down, subtract 1 off. Bring it down, subtract 1 off. Alright, common denominator, if you're not sure how I got those numbers. There you go. Next one, don't let the y scare you. It's the same thing. W prime of y. Bring it down, subtract 1 off. 24y cubed. Bring it down, subtract 1 off. Now remember, we're multiplying this. 7 over 1 times 2/3 is the easiest way to do it. So I get plus 14 over 3 y to the negative 1/3. Common denominator. So that'll be my answer. The next one, now for all the stuff we learned so far, only thing I could do is, you can't just like take a derivative with the stuff we learned so far. So I have to rewrite this. So 5s plus 1 times 5s plus 1. Then we distribute 25s squared plus 5s plus 5s plus 1. That gets us 25s squared plus 10s plus 1. That should have been a 1 there. Okay, Now again, I just rewrote it. That's all I did. I haven't taken any math. I did math. I haven't done any calculus yet. So now we can take a derivative. And you guys can go much faster to do that. I was just trying to show all the steps. So derivative of this guy, or prime of s, would be, bring it down, subtract 1 off, 50s plus 10s. The derivative of 1 goes away because it's a constant. And it should not be 50s times plus s. 50s, come on, go back, there you go. That's the answer. Bring the 2 down, subtract 1 off, 50s plus, it's a linear term, so the s just goes away, you just get 10. And the derivative of 1 is 0. Same thing right here. Again, we haven't learned anything special yet, so all we know is power rule. So only using power, we have to distribute this first. So 6z squared plus 3z minus 2z minus 1. Out like terms. Plus z minus 1. Again, that's normal. Now take a derivative. And we get 12z plus 1. Right? Bring the 2 down, subtract 1 off. Right here, the coefficient of z is just 1. And then again, the constant goes away. More derivatives. So this is actually very similar. I can't just take derivatives. I got to distribute it out. But first I got to rewrite this. So I got to do a lot of algebra first. So this is t to the 1/2 times t plus 1. Then we can distribute. Now this has a power of 1 there. So remember, you're adding, when you multiply, you add the powers. So 1 plus 1/2, also known as common denominator, 2/2, 3/2. So t to the 3/2 plus t to the 1/2. This is what my function is. And like before, I always say, we still take a derivative. We haven't done any derivatives yet. Now take a derivative. So g prime of t, bring it down, subtract 1 off, 3/2. T, remember 3/2 minus 1 would be 2/2, would be 1/2. Plus, bring the 1/2 down, subtract 1 off. 1/2 t. 1/2 minus 1 is negative 1/2. So I get that. Next one, e squared. Notice something about this one? There's no x. So this is just a number. It's like taking the root of 5. It's going to be 0. This is a constant. It's just a number. So my answer here, my derivative, is just 0. Easy. Next we have an e here. So for me, e's are my favorite. I think they're so easy. Right, so you just bring the 3 down, and then the derivative of ex is just ex. Boom. This one, bring the 3 down, subtract 1 off, minus 3x squared. There we go. This next one, another one where we have to do a little algebra first. I can't take a derivative by dividing yet. Soon though. So we gotta do some algebra first. So rewrite it, x to the 1/2 plus 1/x. That helps, but we're still not done. I still can't do anything, so you gotta split it. Alright, you can always split the denominator. You can't split the numerators like that, but if there's only one thing in the denominator, then you can split it. So it goes like this. X to the 1/2 over x plus 1/x. X to the 1/2 over x. Remember, this is a 1 down here. All we do is 1/2 minus 1 would be negative 1/2. So we get y equals x to the negative 1/2 plus, and then we want to rewrite this. Remember, move to the top, so it becomes x to the negative 1. And like I always say, we haven't done any calculus yet, right? We just rewrote it to be pretty. Now we can take a derivative. So y prime equals, bring this down, subtract 1 off, negative 1/2, x to the negative 3/2, because common denominator, bring it down, subtract 1 off, plus, actually be minus, but whatever, right here, negative 1, x to the negative 2. So we have that. That's our derivative. But now we want to plug in 16. So when you want to plug stuff in, it's a lot easier if you rewrite it nicer. So let's rewrite it. Negative 1/2 times 1 over x to the 3/2 plus negative 1 over x squared. I meant to put minus there, but I already put the plus. I just went with it. So now I can plug in 16. So I get negative 1/2 times 1 over 16 to the 3/2 plus negative 1 over 16 squared. 16 3/2, right? You always want to do a square root first, so square root of 16 is 4. 4 cubed is 64. So I'm going to get negative 1/2 times 1 over 64 plus negative 1. 16 squared is 256. So I get let's see, negative 1 over 128 minus 1 over 256. And I can't leave it like that, but luckily, if you multiply this by 2, we get the same denominator. So negative 2 over 256 minus negative 1 over 256, well, plus negative 1 over 256, gets me negative 3 over 256. And that is the answer to that. Okay, back up. So now this one, t equals 3c to the 2/3. Find dt dc. So that means that c is your variable. So that just pretend that's an x. That's all that is. So take a derivative. Bring this down, subtract 1 off. If we bring that down, you're left with this 3 times 2/3 c to the negative 1/3. Right? These cancel. So my dt dc, the derivative with respect to c is what that means, equals 2c to the negative 1/3. Now, like before, we're going to plug in 8 or sub in 8. So let me write it a little nicer. This is 2 over 1 times 1 over c to the 1/3, just so you see a little nicer. Now let's plug in 8. So I get 2 times 1 over cube root of 8, which is just 2. So 2, 1 over 2, it's just 1. Isn't that a blast? Okay, next one. So same idea. P equals 7 over v, which really just equals 7v to negative 1. I gave you that one. I wasn't supposed to. So yeah, I flipped it up and you got this. That's a little present from me to you. So now take the derivative with respect to v. Take the derivative of p. Take the derivative of the function p with respect to v is what that says right there. And then sub in negative 2. So again, do a little favor, gave you this. So now the derivative would be just bring it down, subtract 1 off. Negative 7v to the negative 2. Again, since I'm plugging in negative 2, let's rewrite it to make it a little bit nicer. So negative 7 over v squared. Now let's plug in negative 2. Negative 7 over negative 2 squared, which gets me negative 7 over 4. Done. Next one. R equals w pi, find dr dw. So remember when you see this, the one on the bottom is a variable. That's like your x. My x here is like a w. So we're just taking a derivative of this guy. So bring the pi down, subtract 1 off. So r prime equals pi w pi minus 1. That. So just bring the pi down, subtract 1 off. Now we want to plug in 1. So we get pi times 1 to the pi minus 1. Now remember, 1 to any power is just 1. So this is just pi times 1 really. Which is pi. So again, 1 to any power is just 1. So then you get pi times 1, which is just pi. Moving on. R is a variable. Little r is a constant. So it's a really, this messes with your mind. So keep in mind, r is the variable. R is your x. Capital R, should say. Capital R is like your x. Little r is like a number. It's a constant. So this just means it's a number. And this is a variable, like x. This is the first one. Take the derivative with respect to r. So if that's like a variable, that's x. What's the derivative of x? 1. And there we go. Done. How about the next one? Remember, r is a constant. It's a number. What's the derivative of constant? 0. It's like taking the derivative of 4 to 0. Now the next one. This looks freaky, right? It's r squared, r cubed. I thought we didn't learn how to take a derivative of multiplying. This is not that. This is a constant times a variable. This is like saying 5 squared times x cubed, right? That's all that is. Bring the 3 down, subtract 1 off. Same thing here. Bring the 3 down, subtract 1 off, so I get 3 little r squared, big R squared. And that's the derivative of that thing, right? Confusing, I know. Okay, next one. Sketch the graph of f of x equals x minus 3x squared and find the values of x where the tangent line to f of x is horizontal. Note that a tangent line is horizontal when the derivative equals 0. So they want me to sketch the graph. So we're going to do a little sketch, not a perfect sketch. Now generally want to find are the x-intercepts. So let's say we have f of x equals x minus 3x squared. I'm going to factor out an x. So I get 1 minus 3x. So my x-intercepts are at 0 and at 1/3. X equals 0 plus 1/3. So at 0 and at 1/3, my x-intercepts, It's a negative x squared, so it opens down. Like that. What we want to find out is, where is this guy? Like, what value is that at? Well, it's at 1 over 6, right? It's always, if you know parabola, it's always halfway between these two. So I know this is 0, I know that's 1/3. That's going to be 1 over 6. So x equals 1 over 6. So how do we do that without graphing? Well, we don't have a nicely perfect one there. Well, we could take a derivative set equal to 0. We just do what this thing says. So let's go back here and let's do that. So let's take a derivative, which would be 1 minus 6x. Right, the derivative of x is 1. The derivative here is bring it down, subtract 1 off. So I have this. Set equal to 0. Then let's solve it. Same answer. A lot easier the second way, I would say. Next one, find the points on the curve at which the slope of the tangent line is equal to 4. So it literally just says, find the points on this curve where the slope of the tangent line equals 4. Slope of a tangent line, again, just means derivative. So all we want to figure out is where this y prime equals 4. So let's find out what y prime is. Bring it down, subtract 1 off, 2x. The derivative of 3x is just 3. The derivative of 7 is a constant, so 0. So we get this, set equal to 4. So 2x equals 1, x equals 1/2. There we go. If you wonder what we're doing there, right? Let's look with the power, like that graph, like a parabola like this. We're trying to figure out where the slope of that thing, the slope of the tangent line of this guy equals 4. That's what happened at 1/2. So we draw a tangent line there. The slope of that guy would be 4. That's what was going on. That's what we found. Okay, the next one, number 54. Sketch the graphs of f of x equals x squared minus 5x plus 4 and g of x equals negative 2x plus 3. Find the values of x over which the graphs have parallel tangent. Remember, tangent line in general means derivative. So find all the values of which the graphs have parallel tangent lines. So it wants to know where the derivatives are equal. That's what's going on here. Because parallel means same slope. And they're talking about tangent lines, so we want to know the derivatives are equal. That's what we're looking for. They did want us to sketch it, so let's sketch it real quick. There we go. So we have that. Okay, how are we going to sketch this? The best way to do it, so when it's parabola, is to factor it, and that factors to x minus 4, x minus 1. So my x-intercepts are going to be at 1 and 4. So 1 and at 2, 3, 4. Then it's a positive, so it's opening up. So it looks something to this effect. Something to that effect. And then negative 2x plus 3. So line at it's a line with a y-intercept of 3. A slope of negative 2. So down 2 over 1. So something like that, and we just want to figure out when the derivatives of these lines have the same slope. So let's do it mathematically. Let's find the derivative of f prime. That should be 2x minus 5. Right, this guy is 2x minus 5. Let's find the derivative of g prime. That's going to be negative 2. Set them equal to each other. Add 5. 2x equals 3. X equals 3/2. And there we go. Last one. Find out values of x for the tangent lines to y equals x cubed and y equals x 4 are parallel. So pretty much the same question, right? Tangent line means kind of derivative. We want them to be parallel to the same derivatives. So we're looking for where we want to solve for the x values where the derivatives are equal. I was about to say f prime equals g prime, but we don't have f for g. So we want to say where this guy, which is what 4x cubed, is equal to the derivative of this guy, which would be 3x squared. So let's have each other. Now, most common mistake right here, people divide by x squared. You cannot do it. You can't divide by something that might be 0, and x squared might be 0. So we set equal to 0. Right? Anything higher than x, we set equal to 0. So we're going to get 4x cubed minus 3x squared equals 0. Subtract 3x squared from both sides. And then here they both have an x squared, so we can factor it out. Then we get 4x minus 3 equals 0. Split it. X squared equals 0. 4x minus 3 equals 0. Square root here. X equals 0. This is why you can divide by it. And then over here, 4x equals 3. X equals 3/4. There we go. Done. With that problem. I just noticed there's an extra one. I thought that we were done. We got a few more. A couple more. We'll be done soon. Sorry about that. So there's a unique point on the graph of the function for ax squared plus bx plus c, where the tangent line is horizontal. Explain graphically. So tangent line being horizontal just means f prime of x equals 0. Right? So tangent line means derivative. Horizontal means the derivative equals 0. So let's take the derivative of this guy and set equal to 0. So how do we take the derivative of this? The key is keep the variables. The variables here are just a, b, c are just numbers. So if we take a derivative of this, just treat like they're numbers. They're constant. So like 2, bring it down, so 2ax. The derivative of this guy, right? It's right. Bx, anytime you take the derivative of a linear term, you just drop. It's all about the coefficient, right? You drop the variable. So b. And again, c is a constant, it's not a variable, it's a number. These are all a, b, c are just numbers, so that goes away. Derivative of 5 is 0, so derivative of c is 0. So we have that, and we can set equal to 0. Solve for x. So subtract b, negative b equals 2ax, divide by 2a. So we get that for our x point. And then, so there's a unique point on the graph. Well, if that's my x, how for my y, you plug it in. So this is going to be the point negative b over 2a, comma, f of negative b over 2a. And that should look familiar to most of you guys. If we're talking about parabola. Right? If we're talking about parabola, that's how you find the vertex. Right? Remember the axis symmetry? X equals negative b over 2a. If you want to find the vertex, plug it back in. That's where it comes from. Okay, one last one. Determine the coefficients a and b such that p of x equals x squared plus ax plus b. Satisfy if p of 1 equals 0, and p prime of 1 equals 4. So a couple things going on here, right? So they're asking for p of x. And they're asking us about p prime of x. And there's this right here about p prime of x. Well, let's figure out what p prime of x is. Just like we did earlier, right? Take a derivative of this. Bring the 2 down, subtract 1 off. 2x. The derivative of ax is just a. And derivative of b is going to be 0. B is a constant, a is a constant, so derivative of b just goes away. So we have this. Now let's plug in what they give us. For the original function, when I plug in 1, it equals 0. So right, you're subbing in 1 for all your x's, and it sets it equal to 0. So p of 1 equals 1 squared plus a times 1 plus b. But remember, this is just 0. So it's 1 plus a plus b, or negative 1 equals a plus b. So I have that. On this side, right here, when I sub in 1, it equals 4. So p prime of 1 equals 2 times 1 plus a. So this again is just 4 equals 2 plus a. So a equals 2. Done with that. Find b now, plug it in. So negative 1 equals 2 plus b. Subtract 2. Negative 3 equals b. So there's my b, there's my a, and now we are actually done with this worksheet.